Hi everyone, it's Adam again. This is the fifth video of Maths Paper 1 and I'm moving on to Algebra 2. So this sort of stuff is basically how you just solve equations and manipulate formula to make it solvable or easier to use, you know? So without further ado, we can start. So it's just how do you solve something like linear equations? So if we have something like what you want is, if you have something, the reason this is important is because in an awful lot of calculations it'll simplify down to a linear equation, so that's why you need to know how to solve linear. Then when we solve quadratic, there'll be like a first part, and then you'll have to solve another linear equation. So everything basically comes down to solving linear equations. So you might have something like 2x plus 4 equals 2. So what you can do is, I want to end up with x equals ... So this is the form that I want to end up with. So the idea is you want to isolate x on its own. So on the left hand side, I have 2x. So first of all, I have 2 x's, I only want 1. And second of all, I have a plus 4. So first things first, let's get rid of the plus 4. So what I can do is, if I want to get rid of plus 4, all I have to do is the opposite of it to get rid of it, okay? So what I can do is, I can minus 4 on both sides. So both sides are equal, and therefore, if I want to do anything to them, I must also do the same thing on the other side to ensure that they stay equal, okay? This is the idea. So now that I have minus 4, I'll do this, and I'll get 2x equals minus 2. Okay? Now I have 2 x's, I only want 1 x. So now what you do in this case is, you want to divide by 2 on both sides. Okay? The reason I want to do this is because now 2x divided by 2 is simply x, and minus 2 divided by 2 is simply minus 1. So we get finally that x equals minus 1 is the solution to the linear equation above. Okay? Hopefully this is fine. I'll do a couple more, but hopefully this is this would have been covered in junior cert, so hopefully this is all fine. So feel free to skip the 5-10 minutes of this video that I'll be talking about linear equations. So there's another one. It could be something like 2 into x plus 3 equals 18. Okay? So now, there's a couple of ways of doing it, but my advice is that if you're looking at that and you're saying, I don't know how to solve that, think, what makes it hard? So what makes this different to the one we just did? So what's the difference between this and this? The difference is that there's brackets, okay? So I can just get rid of the brackets. So how am I going to do that? To get rid of the brackets, I can just multiply it in. So 2 bracket x plus 3 bracket. What does that mean? That means 2 multiplied by x plus 3. So if I do 2 multiplied by x, I get 2x. And then 2 multiplied by plus 3 is plus 6. And it equals 18. And now all of a sudden we have the exact same thing that we had above, just with different numbers. So again, I have 2x plus 6. I just want x on its own, so I want to minus 6 from both sides. Okay? So now that I've done this, I'll end up with 2x plus 6 minus 6 is just 2x. 18 minus 6 is 12. Again, I'm going to divide by 2 on both sides. And this will simply give me x equals 6. And that is the final answer. Okay? So that's all you have to do. You just want to end up with x equals something, and then you just do the necessary steps to get it to that. Okay? I'll do one more. So it could be something like 2x minus 5 over 2 minus x minus 3 all over 7 equals 3. Now, in the last video, when I talked about adding and minusing fractions, I said that you had to keep the value the same, which is true. Because if I said a half plus a third, and then you gave me something like 10, I'd say, well, that's obviously not the case. So in that case, we needed the value to stay the same. Here, we couldn't care less. See back up above, the way I just divided by 2 twice. So I divided by 2 in the first equation, and I divided by 2 in the second equation. So there's no consequence here for multiplying an equation by 2 or dividing it by 2 or adding 7 to both sides. There's no consequence for it. And therefore you can do it, and therefore we would take advantage of it. So here, so again, ask yourself, what's awkward about this equation? The 2 and the 7. Okay, so here, I'm dividing by 2. So why don't I just multiply by 2? Why don't I just multiply my whole equation by 2 to get rid of my 2? Okay, so if I multiply everything by 2, this becomes 2x minus 5. Okay, so in the first term, what you're saying is you're saying 2x minus 5 divided by 2 multiplied by 2. So it's just 2x minus 5. We get minus, multiply the next one by 2, it's going to be 2x minus 6 over 7 equals 3 multiplied by 2 is 6. Okay, so I've just multiplied everything by 2. That's what I've done. So 2 multiplied by x is 2x, 2 multiplied by minus 3 is minus 6, and that's where this came from. Okay, so I just multiplied this by 2 to get that. Okay, hopefully everybody sees that. So now, what's awkward about this? The 7. So in this case, I'm just going to multiply by 7. So 7 multiplied by 2x is 14x. 2 multiplied by minus 5 is minus 35. 2x minus 6. So now be careful. We're minusing the entire thing. Okay? So when I multiply by 7, the 7 on the bottom, so the blue 7 on the bottom just disappears when you multiply by 7. That's why I multiply by 7 to get rid of it. So I'm just left with minus 2x plus 6. Okay? Hopefully everybody sees that it's minus by minus, you get a plus, because I'm minusing the whole fraction off of it. Okay? Equals 6 by 7 is 42. Okay? So now, here I have an x, here I have an x, here I have a constant, and here I have a constant. So I'm just going to add those terms together. So 14x minus 2x is 12x. Minus 35 plus 6 is minus 29. And that equals 42. Okay? So this then, I get 12x is equal to 42 plus 29. That's going to be 71. And again, I've 12 x's, I only want one, so I'm going to divide. Here I'm dividing by 12, and here I added 29 to both sides. in case you're wondering where the 71 has come from. So I get 71 divided by 12. And that's the final answer. So yeah, that's all it was. So you started from the top equation there. You said here, listen, I don't want the 2 and the 7, and therefore I'm going to multiply by 2 first and then by 7. You could have multiplied by 14 if you wanted to. That is completely fine. I just took it in 2 steps, but you definitely could have done that in 1 step, in 1 go if you wanted. Or 1 foul swoop if you want to call it that too. So yeah, that is that. So hopefully that has that clears up the linear equations. So yeah. Now we have simultaneous equations, which is quite another beast. Okay, so for simultaneous equations, what you have is you'll have something like x plus y equals 4, and you'll have x minus y equals 10. And then you're asked to solve this. Now, the reason that these are called simultaneous equations is basically, so simultaneous means at the same time. So x plus y has to equal 4. But the thing is, there's tons of answers for that. X could be 0, y could be 4, because 0 plus 4 is 4. X could be 2, y could be 2. 2 plus 2 is 4. X could be 4 and y could be 0. So there's multiple answers to it. But there's only one answer in which x plus y is 4 and x minus y is 10. And that's what you're going to do here. So you always want to end up with, in these equations, the same number of y's or the same number of x's. Here we have the same number of x's and the same number of y's. And when I say number, I couldn't care less about the minus sign. Okay, so you just want that if there's a 7, if it's 7x, you want to have, 7x's and 7x's, plus or minus. You couldn't care less, as long as they have the same number of them, So here, we both have 1x and we both have 1y, perfect. So we can choose to get rid of one or the other. I'm going to choose to get rid of y. Now, how am I going to do that? You simply add the equations together. Why am I doing that? Because I know y plus y minus y equals 0. So y goes, it's gone. You could also minus here, because x minus x is 0, and then your x's would disappear. But I'm just going to add. But it's completely up to you, to your preference. It does not matter which you choose. You'll get the same answer. So if I add, I get 2x plus 0y equals 14. So I get 2x equals 14. I'm going to divide both sides by 2. And I get x equals 7. Okay, so now you plug this back up into one of your equations up here. So I'm going to plug it into the top one. So x is 7. That means that x plus y is the same thing as 7 plus y. And I know this equals 4. Now I'm going to minus 7 off both sides. So I get y equals minus 3. So x, and this is the way you should write it. The reason you should write it this way is because x plus y equals 4 is a line in 2D. And x minus y equals 10 is also a line in 2D. So that means that what you're after calculating is the intersection between the two lines. Okay? So I'll just draw a quick thing here. It's like this. Say this is 8. It's minus 8. This is x. That's y. That's 8. And that's 8. This line, this is the y equals 4 minus x line. So that means that so we'll do it later, so you can just trust me now, but I'll explain this when we're doing trigonometry and coordinate geometry. If I plug in 0, I get this point, and it's just a straight line down. Which means that is the line. Okay? I'll get a new colour. One that you'll probably be able to see. I think you'll probably be able to see this. So now, the other one, the second line, this is the y equals x minus 10 line. Okay? So, what we have is that your y-intercept is actually minus 10. So your y-intercept is here, and it has slope 1. Which means it'll look like this. So this here is your point of intersection, which is approximately at minus 3 and approximately at 7, because I'm taking that this is 2 and this is 4 and this here is 6, so that's roughly 7, and then this would be 2 and this would, so minus 2, and this would be minus 4. So it's roughly in between there. My drawing could be a bit better, but you get the gist. So yeah, this point here, that's what you're solving for, and that's why I wrote it like a point, because it is. So maybe when you're looking at these videos, you've already done coordinate geometry. Like this could be, realistically, you could be watching this the night before your leaving cert. But just if you haven't done coordinate geometry and you're watching this video, just trust me that this is how it is done. And there will be videos that will cover this in a lot more detail, but this is just the gist of what you're solving for, okay? Because the second you introduce z and it's x, y, and z, then it's in 3D, and I can't draw that. I'm not good enough to draw it. So yeah, I'll skip that. But yeah, that is how you do those. I'll do another one or two. Maybe I'll just do one more, because they're just the exact same thing. So here, you could have something like 7r minus 4s plus 1 equals 0, and 4r minus 7s plus 43 equals 0. So again, you always want the same number of r's or the same number of s's. I'm going to choose to get rid of s. Okay? And you could choose to get rid of r, but I'm just going to choose to get rid of s. So I want to know what is the smallest number, what is the lowest common multiple of 4 and 7? The answer is 28. So I'm going to multiply the top equation by 7 and the bottom equation by 4. Okay, so this equation holds. So the left-hand side of both equations are just 0. And therefore, if I multiply them by 7 and 4 respectively, I still get 0. So I'm completely within my right to do this. So if I multiply the top one by 7, I'm going to get 49, or minus 28 4s plus 7 equals 0. And now if I multiply the bottom one by 4, I'm going to get 16r minus 28s plus 172. And that equals 0. Now I'm going to call this equation 1 and this equation 2. I'm going to do equation 1 minus equation 2. So 49r minus 16r, this is going to be 33r, minus 28s minus 28s is minus 28s plus 28s, so 0. 7 minus 172 is minus 165. And this equals 0. Okay? So I'm going to add 165 to both sides, because again I'm trying to isolate r. So I get 33r equals 165. Just trust me, divide this by 33, look in your calculator, r equals 5. Okay, so now that I have r equals 5, I can just plug it into one of the equations and solve for the other thing. So I'm going to plug it into equation, I'm going to plug this in there. So 7r is 7 multiplied by r, but r is 5, and therefore 7 by 5 is 35. Okay? Minus 4s plus 1 equals 0. So I get 36, so 35 plus 1 is 36, minus 4s equals 0. So I get that 36 is going to be equal to 4s. So you can add 4s to both sides, or if ever you're going to transfer a number across an equal to sign, it changes sign. Okay? So in this case, it goes from minus to plus, or it goes from plus to minus. Okay? So whenever you bring something across an equal to sign, it changes sign. Okay? Which you can see here. When I was adding 165 to both sides. Okay, sorry, that's I'll just do this. So when you're adding 165 to both sides, in this case, it cancels, but at the same time, it has the effect of just saying, oh, well, you can just bring the minus 165 across the equal to sign and it becomes plus. Which is what happens here. Okay? So I get this, and I'm going to divide both sides by 4 now. And I get that s equals 9. And therefore, rs is going to equal 5, 9. And that's your final answer for that. Okay? Now, that was again covered in junior cert, so hopefully that's okay. Now I'm going to move on to its simultaneous equations with 3 variables. So now with 3 variables, things have gotten a lot more difficult. So now you're asked to solve 2x plus y plus 4z equals 23, 5x plus y plus 2z equals 19, and then 3x minus 2y plus z equals 13. Okay, so again, this is going to be a big massive theme that I'm going to keep reiterating, and hopefully it will stick for a lot of you. Is there any reason for me to change my approach from 2 variables to 3? No. The answer is no. You are going to do the exact same thing. There is no reason to change anything. Okay? I'm still going to get rid of one variable. I'm going to get rid of one variable. Then I'm going to have two of them. And then I'm going to get rid of the second one and just have a single one left. Okay, so I'm going to do the exact same thing. So again, I want all the same number of x's, same number of y's, or same number of z's. Now, I'm going to get rid of y. Okay? Now, you don't have to do that, but, I'm personally going to do that. So, I'm going to make sure that all the y's have the same, all the equations have the same number of y's. So I'm going to multiply the top two equations by 2. So I'll have 2 y's, and then there's already a 2 in the third equation. So if I rewrite these, multiply them by 2, I'm going to get that it's 4x plus 2y plus 8z equals 46. I'm going to get that it's 10x plus 2y plus 4z equals 38. And then the last equation is just the exact same as what it was. Okay, call this equation 1, equation 2, and equation 3. Okay, so again, I want to get rid of the y's. So I can do equation 1 plus equation 3. And then this is going to give me, when I do this, if I add those two equations, I'm going to get 4x plus 3x is 7x. 2y minus 2y is 0. 8z plus z is plus 9z. 46 plus 13 is going to be 59. Okay? And I can also do equation 2 plus equation 3. Because this is a fundamental thing in maths that basically, the reason before when there was only 2 variables and we were asked to solve it, we were given 2 equations. Now there's 3 variables and we've been given 3 equations. Basically, if you have 3 things you do not know, you need 3 bits of information to suss out what they are. That's why here there's 3 equations. And now that I'm getting rid of one variable, I still have 2 variables. I still have x and z. That's why I'm doing this thing a second time, to get a second equation so I can figure it out. So I have sufficient information to determine what x and z are. So if I do equation 2 plus equation 3, I'm going to get 13x plus 5z equals, this is going to be 51. Okay? Okay, that looks a little bit dodgy. So 51. Now it's back to the same equation that we were just doing. Now I'm just going to basically make sure there's the same number of x and the same number of x's or the same number of z's. I'm going to choose the z's, so to get rid of the z's, just because I can multiply by a smaller number. That is absolutely the only reason I'm doing this. So I'm going to multiply the top equation by 5 and the bottom equation by 9, because the lowest common multiple of 9 and 5 is 45, and therefore I want to multiply the 9 by 5 to get 45 and the 5 by 9 to get 45. So when I do this, I'm going to get 35x plus 45z equals 295. Yep. And then this one then, this is going to be 117x plus 45z equals that's going to be 459. Okay, now I can minus these equations off each other. So now I'm going to call this equation 4, this equation 5. I'm going to do equation 5 minus equation 4. So 117 minus 35 is going to be 82. 45z minus 45z is just 0. 459 minus 295 is 164. Okay, thank God this simplifies down. The numbers were getting very big for a second. Okay, so now I can divide both sides by 82, and I just get that x equals 2. So now I have solved for x. Now I plug this back into one of your equations to figure out what z is. So this gives me 7 times 2, which is 14, plus 9z is equal to 59. So I get that 9z, so minus 59 minus 14 is 45, so z equals 5. And now I'm going to plug both of these back into the top equation. So now I'm going back to the original equations to solve for what y is. So this is 3x, which is 3 times 2, so 6, minus 2y, plus z, so plus 5, and that equals 13. 6 plus 5 is 11, minus 2y equals 13. So we get that minus 2y equals 2, so y equals minus 1. So this means that your point, which is now in 3D space because it's x, y, and z, is equal to 2, minus 1, and 5. And that is the final answer. Okay, so hopefully that makes sense. I'll do another 1, maybe 2, depending. I might do one very hard one. There's one question here in my book that just looks awful, so I might just do it just to have it. Okay, so another one we can do is something like, we can solve x plus y plus z equals 5, 2x minus y plus 3z equals 3, and 3x plus 2y minus 5z equals 21. So again, call this equation 1 and this equation 2. I can do equation 1 plus equation 2. So again, I'm getting rid of y's. Again, really, I'm being completely honest. You genuinely, it does not matter which you get rid of. I know I've gotten rid of y's both times, but it genuinely doesn't matter. I just, by looking at it, it just looks like the easiest one for me. It's the first thing I see. So I'm going to add these two things together because plus y minus y is 0. So I get x plus 2x is 3x. 3z plus z is 4z. And then 5 plus 3 is 8. Okay? So that is now that. So now, call this equation 3. This is 2y's. So what I can do is I can do equation 3 plus 2 times equation 2. Okay? So this gives me 3x plus 2 times 2x, so 4x, so it's 7x. 2y minus 2y is 0, minus 5z plus 6z is plus z, and 21 plus 2 times 3 is 6, so 27. Okay? So again, I'm going to get rid of z's from these two equations, so I'm going to multiply the bottom equation by 4. So this gives me 28x plus 4z equals 108. And then the top equation is 3x plus 4z equals 8. So I'm going to minus these from one another to get rid of the 4z's. So I get 28 minus 3 is 25. 4z minus 4z is 0. 108 minus 8 is 100. Divide both sides by 25, I get x equals 4. Okay. Subbing back into the first equation, we get that 12 plus 4z equals 8, which means 4z equals minus 4, and so z equals minus 1. And again, I'm going to plug both of these back into equation 1. So back into equation 1, we get 4 plus y minus 1 equals 5, so y plus 3 equals 5, so y equals 2. So your point for your answer is again x, which is 4, 2, minus 1. Okay? So, yeah, I think we can leave it there. A for time and B, because I think that's enough on how to do those. So yeah, those are how you do simultaneous equations. A lot of people love these for some reason. They just find it easy. I don't really know why, but they do. So yeah, maybe you like the chapter, maybe you don't, but it is a thing that comes up a lot in the Leaving Cert, so I would recommend to have a good go at it and wrap your head around it as soon as possible. And yeah, that's it. That's it from me. Thank you very much for listening, and yeah, thanks very much.